Hello, I am James Killian, and I'm going to host this 2014 demo, and I'm going to go through basically some of the new things that we're dealing with beta. So first, I'm going to go to this robot setting here, and if you look right, let's see, right. Hold on a second. Right there's a little green square. This is the new feature for the compositor. Now, one of the things you can do is you can take and click this little edit button, and now I can move it around wherever I want. And the way I'm doing this, if you look, you can see with the joystick right here, I'm actually moving the position. Now, the idea here is that if you have a manual solution and you want to align the robot to a mark, to a target, you can place that wherever. And so the way this works is it has different, you can have different sequences, and I've assigned it to the POV hat. So like there's that one, and I've assigned a secondary one here. You can move that around, and it's the same idea. Now, with this example, this shows you an idea where you can have multiple pieces. So what I can do here is I can take my group edit. Now it's only going to do one of them, and I can actually take and have multiple markers. So like, for example, on the pyramid, if you wanted to have multiple marks that you wanted to do, you can step through and move these however you want. And by default, I have them put together, and then if you like, you can regroup them, and then you can move them around wherever you want. Okay, now the next one, so I'm going to go ahead and take off edit. It flashes whenever edit's on, or you can flash it, or when it's off. Also, you can edit position in the menu. So if you don't have the other smart dashboard piece, you can still do it from within there. Okay, in this clip here, it's going to show where this is really useful. If you see this right here, this green square, I went ahead and manually aligned it to where it should be, where the frisbees go. And watch how we didn't have it quite aligned right, but we were trying to use dead reckoning to align it. And you'll see how we try to adjust where we're going. You see they're doing it right now, and we're trying to get it aligned right. Oh, look at that. That would not make it. No. That's better. Better. And so you can see where it would come in really handy to have something that when you get it aligned, that it would do the right thing. So let's just watch here for a minute and see what happens whenever autonomous starts. There it goes. Here's autonomous. There's ours. So you can see it hits the mark, but the mark wasn't right where it's supposed to be. So you can see here why it's important to have some kind of mark that you can quickly adjust whenever you're playing. And of course, we didn't have the camera aligned directly to it, so that's why I made that. Okay, and then right here we have how you could use like multiple markers. You can see that I put them right there, and you can move them around, adjust them however you want. It's just some idea if you needed more than one mark to help you align it properly. And so there's an example of that. Okay, in this example, you can see the bypass plugin for processing vision is in use here. One of the things you can do is you can open the vision here and see how I have it set up. If I put on threshold only, you can see that it's got a pretty good lock on it. And now if I put the bounds text, it'll see anything that has false positives, and as I increase these settings out, you'll be able to see more false positives come in. Yeah, here they come. Yeah, see, so the idea is that you can tune them all out and get your ideal goal that you want to use. So that's that. Okay, in this demo I'm showing the line plot feature, which you can see right here. The red line shows where I'd like it to be on its position. The blue line shows where it actually is. Over here you can see the actual angle of the arm, and I have the height right there. So here we're going to try to do a set point operation. You see some of the settings that help tune it. So here we go. I'm going to put it all the way down to the bottom. There it goes. Whoa. There it goes. Oh, let's try that again this time. Alright, we're going to go up. There you go. You can see it going up. And we'll go back down. See it going down there. Alright, and we'll try a lower setting there. And you can see it scrolls as it goes. Alright, we'll go way up high now. So there you go. And then of course we can do manual control, which is a little bit smoother, and it doesn't use the PID. You can see the yellows just staying where it's supposed to be. So anyway, that's a good example of some of the actual diagramming of the plotting line plot feature that can help you diagnose this as you go. Lower the arm. First I'm going to have this running. Now I'm going to lower it. You can kind of see it coming down. That's funny, you dropped it too. And you can see that the actual graph running, and there, it's finally got it. And now I'm going to put it back up to 9. You can see it going back up. Kind of an interesting thing there. Okay, and now I can freeze it. So there, it's frozen. So now I can analyze the data, and I can do things like I can go in here and I could change this and make it open loop versus closed loop. And right now I've got it tuned sort of cool, but it could probably be improved. As you can see, it's kind of wavy right in here, but that's okay. Anyway, it just sort of illustrates what it can do. Now, one of the things you can do is, if you want to look at this graph a little better, well, there's several ways to do it, but one way, you can take the block amp, and I can quickly lower the brightness of this video. There, now I can see it, you know, the graph a little bit better, what it's doing, and but you can make the graph do whatever you want. And as a matter of fact, I'll show you some. Actually, you know what? Let's go ahead and lower the brightness, because I'm going to show you some other things too. So what I can do is, you can have multiple things that you can look at. So I'll go ahead and continue this. I've got a button that does that, and I'm going to go to the next one. This next one is a drive. So when I do the drive, you can see it's graphing it. Okay, and you can see the voltage and the encoder's doing that. And I also got a different form of this. So this one is like a tank drive. You see the left and the right here on their own tracks, but you can also make it together. So on this one, I've got different colors for one side versus the other side, and I can go the other way. There you go, and you can see it there. And so you can like analyze the data and stuff like that. The other thing you can do is you can actually use a black background with a different frame rate, because this actually takes samples depending on how fast the frame rate is, so you can have a higher resolution for better graphs and stuff like that. So that's pretty much what that does. And so you can also see over here some of these real-time readings, like at the voltage and then encoder readings there. I have velocity and rotation velocity here and stuff like that. And you saw my arm voltage as I was raising and lowering the arm there. I got a, let's see if the rollers work. There you go, rollers. See that graph right there. So anyway, and also right here you can see this shows what sequence it is. So now it's back to 1, 2, and you can have as many sequences as you want. So the next piece I'm going to show is okay, in this example we can show how it's possible to use a robot simulation to work with the smart dashboard. In this example, I'll show the usage of the arm, and you can see it going up here. So it's not using a real robot. In this case, it's being simulated. Here, I'll go back down. You also notice that I'm using the black background, using a higher resolution with a faster frame rate, so you can see it scrolling faster. So you can see a better resolution. Now you can use this black frame for the real robot as well. Now let me show you the drive again. So in this case, we can see the left and the right tracks working in their own offsets. You can see it's pretty similar to how the real one is. It's being simulated as well. Now let's look at this other one where they're combined as one. So when they go forward, they look pretty similar, and when they go back, they look pretty similar. When you turn left and right, that's when you can see the difference. And what I did is I used different colors for the red and the blue versus the cyan and magenta, so you can see which side's doing what. And then on the bottom you can see the robot rotating around, moving, so you can give some idea of what's happening with the displacement. And it's also got, you see the little treads on the graphic layout there, so you can kind of get an idea of what it's doing. So anyway, that's one thing you can do with the simulation. And simulation is pretty powerful in the fact that we start out the 6-week build period, we don't have a robot, so it's nice to be able to get some code churned out and have something to test on before you have it. And so it's easy to navigate to which sequence you want to use, and then you can look at whatever graph. So now I'm doing the arm again. So, and you can freeze them so you can see it, what it's doing, and that's it. Okay, when looking at this script, you see this first part here. This is for the load persistence. You shouldn't really need to mess with it that much. You can see that it loads a compositor save.lua here. You can change that, but it will actually save it to that by default. And then right here, you can see the bypass plugin. So whatever the plugin name that you create. In this example, we use Processing Vision, the plugin that comes in included with the source code. So you can see that that's the plugin that we use for when you have it in bypass mode. And this next section here has the X and Y scaler, where these represent the joystick sensitivity when you need to adjust your position of where you want to move it to. If it's too fast, you can lower it, or if it's too slow, you can, make it a larger number, then, adjust it accordingly. So what I did is we have what we call the square reticles, which is those first two that you saw. And all I did was I just simply set how thick I wanted them, the opacity setting, how transparent it is. And this first one, if you look at it real close, you can't see it, but it's got a shadow so that if you're against something bright, you can see, you can still see it with the shadow or not. And if you use the shadow, you usually want to exclude the region. If you don't, it does still look cool, but I just went ahead and did that. You can pick what color your shadow is, and so that's how that first square reticle is. So you can see how it looks. The second square reticle has it without the shadow, and I just picked the color, but it's only one piece of it. Okay, and then the third square reticle is that other piece, and you'll see how those two combine later on down here. So basically, you enumerate all the different square reticles that you want. It's always one piece. So when you saw those two pieces that were combined together, you'll see how that works. So let me scroll down a little bit more. Okay, so this next piece shows how I did the line plots. So the idea is that you pick whatever network variables that you want to look at, and so in your robot code you actually be populating with whatever values you're interested in. In this case, I picked some of these for the ARM settings, and you can see I picked what colors they are, and each one can be of whatever their own scale is. And so these got reduced. The idea is that you want the scale to end up being -1 to 1, so you have to scale them down appropriately, otherwise you get clipping. You can make them extra small or whatever, so that's why you do the scaler. So that shows this one for the ARM readout. Okay, so this next one shows the drive, and it makes use of this thing called the offset, and this made it possible to where I could show the right readings a little bit down below, and the left readings a little bit above. You can see how I have left and right here on some of these names that I'm looking for. And then finally on this last one, this one showed a combined of left and right all using the same, well, there's no offset there, so it's going to center it. Each one has their own certain scale or whatever it is. And then what I did was I used different colors for left versus right so that you can see the difference. Okay, so the next piece is the sequence. So the idea is that you can have as many sequences as you want. Typically there would be an autonomous sequence, teleop sequence, and an end-game sequence, but you can have more if you want. You could, for example, have 3 of them and then reserve some of the other ones for any diagnostic things, and that's what I did here. So you can see like and actually this bypass type, it would be the ideal autonomous, because the bypass will bypass whatever plugin that you want to use for any targeting, auto targeting or whatever. You see how I do square here. Now the sequence 2 has a composite, and the composite actually combines 2 different things, and you can actually recursively have composite as many layers as you want. In this case I just have 2 that are composited together, and the idea is that these selection numbers correspond to how you define them up here, and they're all cardinal, so selection 1 would be the square reticle 1, selection 2 would be this square reticle 2, etc. And this same conventions used for the line plots, where you have your selection here, they correspond to the selection with the numbers there. Okay, and then finally in this demo I do joystick assignments, and the ones that you'll want to use is the set XY, or set X-axis, set Y-axis. You can use Control Any right here if you want to use all joysticks, but I recommend that you get the name of your joystick and use it just there so that it's only assigned to one joystick to do it. And the idea is that these only go into effect if you hit the edit button. However, the sequence one is not. That one always happens. So I chose the POV since it doesn't work with the driver station anyhow, so it's a free control to use. And the idea is that it's supposed to be used live during the match, so that if they want to see their markers for the end game, they can do it. So you can see here how I set it to the POV, but you can assign it anywhere. You can even use buttons, and in the demo you'll see where I assigned it to buttons right here. It's commented out, and it's got this next sequence, previous sequence name, and then I just simply you have various different joysticks that I can test with. You can put as many different joysticks as you want here, and it'll still do the right thing. You probably wouldn't want to use the operator and driver joystick in here, because then they both have this same thing, but then again you might. So okay, so there's the demo. I hope you liked it, and I will leave you with this cool SID tune from the Commodore 64. So long.